right, so let's get started. Welcome to re:Invent 2024. This is session FSI310. The topic is BBVA, building a multi-region, multi-country data platform at scale. My name is Ignacio Fernandez. Everybody knows me as Nacho. I work for Amazon Web Services as Principal Solutions Architect in the global financial services industry. And I have here by my side Federico.
Hello, I am Federico Esteban. I am Global Architect of BBVA. And I am very happy today here to share our journey in building our new data platform in AWS.
So, yeah, we would like to provide you a little bit of background on the BBVA Global Data Platform. On June 2023, BBVA announced a strategic partnership with AWS. As part of that transformation into a data and AI-driven organization, BBVA would leverage the broad portfolio of AWS analytics and AI services across its operations to create a new data platform that would be deployed globally at scale, delivering a secure repository of BBVA's operations and customer data. Now, this platform would provide internal business stakeholders with automated business and market insights, increasing operational efficiencies, and attracting new customers to be delighted. This global data platform has been delivered on time and on budget, and we can say today that is live. I would like to say a huge congrats to the BBVA team represented here by Federico Esteban. Huge congrats. Right. So we wanted to draw an analogy between the airline industry and the financial one, being both a regulated environment. So this global data platform in production could be similar to an aircraft which is in flight, and the challenge here was to change the engines of this global data platform while it is in production, which is very similar to the airline being changing the engines while it is in flight. Things that happen is that, yes, we need to have itineraries more efficiently to travel faster and at the very cost effective. We need to cover more destinations. In the terms of data, would be more use cases. We need to also delight our end users, being more effective, change the ways of working of the passengers, those data consumers, data scientists and business analysts in the hundreds, in the thousands. And last but not least, our airplane crew, needs also to be more efficient. So we need also to provide new ways of working for those teams. And those new ways of working, at AWS, we refer those to the distribution of data work in a different manner, which is what we call the modern data community. So in the same way that, in the past, organizations uncover benefits by decoupling and moving from monolith IT to microservices, now the organizations, with regards to data, they would decouple the responsibility to the edges. So rather than having, a single IT organization being responsible for the whole data lifecycle, ingestion, data quality, management, and even the creation of insights, this model is pushing the responsibility into the organizations on the edges, increasing autonomy, ownership, and speed. So we have here a number of roles. The producers, it's hard to be a producer. You are responsible for cataloging the data. You are responsible for metadating the data functionally and technical, especially because you want the data to be discovered faster by the consumers. You also have the IT team, which should become an IT enabler. So we want to simplify the onboarding, provide a more secure environment, and also, perform this sort of training and community, this modern data community as well. And on the right-hand side, we have the consumers. Those are the ones that want to consume the data. Those ones are the ones that want to discover the data faster, want to basically provide or execute their business priorities depending on what is coming from the business itself. And very important here is that we see the revolution in this modern data community happening on the consumer side. Because on the consumer side, consumers also want to become producers. And this is where we come and move also to, and we'll see that later, the concept at BBVA, which is the concept of the sandbox. The sandbox is a group of end users, could be business analysts, data scientists, that have a common priority, a common initiative, where they want to leverage all the modern data platform, but also they would like to basically accelerate and reduce the time to value for the business outcomes. So we will see that concept of sandbox and consumers becoming producers later on. So let me introduce you now with Federico, the BBVA use case, and later we will see all the topics like architecture.
Well, BBVA is a global financial institution. We have presence in more than 25 countries with over 70 million customers, and we have more than 120,000 employees. These employees need data every day to work with our customers, and this is why we need a global data platform at scale. Our journey in data platforms has been very similar to many other enterprises. We started with siloed databases, but soon we have problems with data inconsistency or data duplication. Then we move and unify all our data in our enterprise data warehouses. This technology was fantastic and it worked really well during many years. But the data grew so large that it became impossible to maintain. It was too expensive. In that moment, many companies and us started to experiment with big data technologies. We created our first big data platform called Datio, but we faced two problems. The first one was that these technologies were really complex to maintain and to operate at scale. And the second one was that we were working on-premise, and we realized that very soon we will not be able to satisfy the increasing demand that we have in data volumes and performance. And this is why we decided to move to AWS. We wanted to scale without limits, and we wanted to simplify our architecture using AWS managed services.
And those are the two engines.
Yes.
Datio and ADA. Yeah.
ADA is the call of our platform is called ADA. ADA is a global platform. We have a unified console, and we have more than 6,000 advanced users, data scientists and data analysts, and more than 40,000 data consumers. We have a unified console, but we deploy the platform in two locations. One in Europe to cover the European countries, in the new region of Spain, and one in America, now in North Virginia, but we have plans to move this location to the new Mexico region that is going to be ready soon. We deploy in two locations because we want to avoid latency problems, and we want to be close to our operational systems that feed the platform with data. This is some numbers from the platform. We have more than 4 petabytes of information. We manage around 30,000 tables, and we execute every day more than 50,000 processes to load the platform with information. But the most important number is this 40% annual growth rate that we support during the 5 past years and without signs of slowing down. This is the real reason that we move us to the cloud. And our project was a 3-year project. We started in 2023, developing the new platform. At the same time, we executed 2 other phases, very important phases. One is what we call the pre-migration, focusing in housekeeping the platform and reducing everything that was not necessary, so we were able to reduce the scope of the future migration. And the other one is the regulatory track. We worked with all the regulators to get the approval to move all the data banks to the cloud. This, in some countries, has been very hard because we are one of the first banks that are moving all the information, 100% of the information, to the cloud. In 2024, the platform was built, was ready to start the migration. We started with the European countries, and we just finished a few weeks ago in production with the European countries and shutting down the platform that we have in Europe. And now we are working with the American countries, Argentina, Peru, Colombia, Mexico, and we have plans to finish the migration by mid-2025, and in that moment we will shut down completely the platform on premise. Let me talk about 5 lessons we learned during this project. The first one is complexity. The complexity of this project is not building a new platform. The complexity of this project is migrating everything from on-premise to the new platform to be able to shut down the old platform. The parallel phase, I will talk later more about this phase, is one of the most important parts of the project, but it's really hard to have 2 platforms in parallel running more than 50,000 processes at the same time. So the shorter, the better. And the pre-migration, as I said before, one of the keys of the project. Thanks to the migration, we were able to reduce the scope of the migration in more than 40%. So it was a really important phase for the project to be successful. The regulatory track, as I said, is we have a high effort to get approval from the regulators, so don't underestimate the work that you will need to convince a regulator to move all your data to the cloud. And finally, the shutdown. This is one of the first projects in the bank that is shutting down the old platform. If you want to be able to shut down the old platform, it's something that you have to design from the beginning of the project, if you really want to happen. And now we will talk more about the data architectures that we use in BBVA.
Yeah, thank you. So yeah, let's review that, how we build the ADA at scale based on AWS modern data architecture, reference architecture. When we started the project back by the end of 2022, yes. There were of course, some challenges, but we didn't start with a blank page. We use AWS modern data reference architecture, but there were some premises that we have to combine with. First is the best performance data performance and pricing ratio, being able to use data at any scale, being able also to provide seamless data access, secure, ensure that we also provide functions, as we will see later, to cover data exfiltration, to provide and to reduce the time to value, also simplify the onboarding of the end users, using a unified governance, new ways of working. And last but not least, use services like Amazon SageMaker to provide MLOps to solve business challenges accelerately. But to do this at a scale, we use the modern data analytics reference architecture on AWS in different layers. And this is important because first things that you need to think about is how you are going to allocate the accounts on AWS. The first thing is the ingestion layer. You may use a number of services as ingesting from databases using AWS DMS, using AWS Data Sync to ingest files from different data sources. In the case of BBVA, they had their own tools as well to do this. And we use massively, in the case of BBVA, Amazon EMR to perform these functions. First is you need to think about, hey, I need to copy the full data lake onto AWS, and then I need to provide incremental copies later on. Why? Because I need to validate, once my data is landed on the storage layer, either on S3 in this case, need to validate that the copies that we are performing are correct. Copy between the on-premise on the source and the target on AWS. That's an important, I would say, tools that you need to think over. And last but not least, you need to sync up the data catalog also between, remember, the 2 engines, the engine on-premise and the engine on AWS. So you need to think the data catalog while ingesting data at the same time, but also the data permissions migration as well. So those are processes that need to be performed fully and then incrementally. The other thing is yes, we have a batch process that was running in the engine on-premise, but we have to perform the same batch process running on AWS using, in this case, AWS EMR, because in the on-premise we had a Spark massive data processes, like over 20,000 data processes in Europe. So those are also some challenges here. You need to comply with the performance that the system had for some specific, for example, regulator reports like FSI310 or liquidity calculation. And last but not least, self-service to the end users. The concept of these sandboxes in the consumption layer for them to be able to perform analytical queries via Amazon Athena, use Amazon QuickSight for BI as a service. In the case of SageMaker, of course, MLOps at a scale, and some other service that we may use leveraging the analytics reference architecture on AWS. Those are related to the data, things that we need to bear in mind. But there are also others that when you migrate at a scale, you need to think of. One is CI/CD integration. Yes, you have a repository of all your code which was being used by the end users at a scale, but now you have another platform running on AWS, and you need to also sync those up. So think of that you need to use that repository, and then that repository needs to be fed from both sides. CloudFormation, don't forget that this has to be deployed at a scale. You're not deploying this in one region. Potentially you may deploy it in the many other regions. So you have to provide all the infrastructure as a service, in our case using CloudFormation for the different regions that BBVA will operate. And monitoring for the data realm. So we will use Amazon CloudWatch and AWS CloudTrail, basically to collect all the information coming from that batch processes and many others. For example, also for data security, we want to understand who is doing what in the platform. We'll use all the logging that is collected by AWS CloudTrail. Important as well. Parallel orchestration, this is very important. We have, in the case of BBVA, we are using a third-party orchestrator, BMC Control M. So again, we have our batch running on-premise, we need to have our batch running on AWS, and those need to be run periodically, ensuring that both batch processes are running perfectly in sync. And data protection. We make mistakes. We are humans. You may make a mistake and you need to recover objects, or you need to recover data subsets, or you need this for example, for DORA, to comply with DORA as well, right? And last but not least, BBVA developed a security unified console with, and I think this is also a very important lesson learned, to provide cost protection and cost visibility. We will see that later, but the focus here is basically to collect information coming from the end user activities, which are the ones that may be the outliers in our platform, because as you can see in the center, we have the data platform that is being run by data engineering. Typically, this is more control, but the end users are the ones that we want to control and provide guardrails, and we'll see that later. So with this, let's see the details of the magic.
Now, this is a very high level view of our architecture based on what Nacho has told us before. We are mixing the best of two worlds. We are mixing the data mesh architecture and the data lakehouse architecture. This is the core part of the platform. In this part, we are using the data lakehouse architecture. As you can see, we have different accounts in the platform. One of the most important is the data account in the top corner. In this account, we keep and manage all the information from the platform, and we are using different kinds of storage. We use S3 for low-cost use cases, but we also use Redshift, a very powerful data warehousing technology from AWS, when we need high-performance analytics. We unify all this data in our Glue data catalog, and we use lake formation to centralize all access control to this data. Below, we have the processing account, very important account because it's where we execute every day 50,000 processes. Our main technology for executing is Spark, and this is why we use EMR. We dynamically create and destroy clusters of EMR depending on the load of the system.
In the hundreds, in the
Yes,
thousands.
We have thousands of EMR clusters created and destroyed every day. And we have many other accounts, for example, security account, when we have all the security tools to manage the platform, scheduling, when we use Control M to schedule all these processes, or the account for logging and monitoring, when we centralize all the logs and all CloudTrails information from the platform. And in the right side, we have the consume layer. Here we are using the data mesh architecture. As Nacho said, we create a concept that is a sandbox. We deploy a sandbox for each business area. We have now more than 250 sandboxes deployed. And these sandboxes are deployed in an independent account. We deploy them in an independent account because we want to control the cost and the budget of each business area. So it's much easier if they have their account with the budget assigned. In these sandboxes, we have different tools like Athena, that is one of the tools that they are going to use most, or SageMaker to perform all the analytics and model training. We federate the Glue data catalog from the central account to each of these sandboxes so they can access the information that we have in the central account. And we also deploy some BI tools like QuickSight, but also third-party tools like Domo or MicroStrategy. To be able to be a real data mesh, we need collaboration and data sharing between these sandboxes. And this is why we are using AWS Data Zone. We use Data Zone to have collaboration and sharing of data, but with governance and control.
So yeah, so let's deep dive now into the features that we believe are really interesting around the ADA transformational journey. The first one would be, how do we support the end user's journey through the unified console? Fede, how do we do that?
Yes, our strategy is let users work directly with the AWS services, but sometimes the AWS console is too big and difficult for our users. So sometimes they cannot find what they are looking for. What we have done is building our own console. We call it the unified console. And in this console, they can look and find for the services they really need. Depending on the role, we are offering them different AWS services. With this approach, we avoid costly integrations, and we can use the AWS services directly, taking advantage of the functionality that they are offering in every moment. But there are some functionalities that sometimes are unique for BBVA. We also deploy that functionalities in this console. For example, when we have to authorize data subscription for a user, is something that we cannot do in the AWS console now, and we have developed it in our console. We also implement a lot of other functionalities, but one of the most important are all these widgets that we are offering to the users. So FinOps information, how much they are spending in the account, what services they are using, and the cost evolution during time. So it's a very important tool for the users.
So now, how do you manage data subscriptions for a population of over 6,000 users?
Yes, data democratization is one of our strategic priorities, and we look forward to see how we can do it easily for the users to get access to the information they need. In the other consoles, they can subscribe directly to the information they need. They will use our governance tools to find the information they need, and once they find the tool they need access, from the console they can subscribe. If the information is not sensible, they will get access immediately. For sensible information, an approval for the data owner is required. But now we are much faster than in on-premise. In on-premise, asking for a table can take 1 week, 2 weeks maybe. Now they can get access in seconds.
And how do you organize the data? Because this was basically the foundation when we started the project. So how do we organize the data to perform those data subscriptions for this population of end users?
Yes, as we see it in the previous slide with the architecture, one of the main storage is S3, is where we have the most information. We organize S3 depending on the countries, the security level, or the layer of the platform, creating different buckets. We have 3 security levels, L1 for public data, L2 for sensitive data, and L3 for confidential data. Each bucket uses a different encryption key to ensure security. And the catalog, that is something very important, works as an abstraction layer, so the users don't need to know where is the physical location of the files. We have like a database view. And all the permissions, all the access control is managed by lake formation tags. With lake formation, we can simplify a lot how we manage information and the security of information.
And now, one step further. When we started the project again, I mean, I remember one of the key requirements was data filtration. So how do we prevent data leakage in ADA now?
Yes, as I said before, we have the data of 70 million customers, so security is critical for us. We have to prevent any risk of data leakage, and for that we use an Amazon service that is called Upstream. With Upstream, that is almost invisible for the users, we can protect them from downloading information locally and take that information outside the bank. We deploy an independent upstream fleet for every sandbox. Okay. And we are also able, if they need to download information, we have developed in our own console the functionality for downloading, but with control and governance, so we don't have any risk of data leakage.
Yeah. So next one. And now the migration approach. This is also a lot of thoughts here that invest a lot of time because this was key to keep, the engines running both in parallel, right?
Yes. We make a lot of effort defining how we were going to execute the parallel phase. This is one of the most complex and most important parts of the project. What we are trying here is to have in parallel both platforms and execute everything in parallel until both platforms have the same result. We started with our on-premise platform, and we have thousands of operational systems that are sending every day the files to our platforms. Our data engineers created thousands of jobs that are ingesting this information in the data on-premise platform.
Including also transmissions from the countries as well.
Yes, we have transmission from different countries and different operational systems. More than 15,000 transmissions every day. And our users are consuming this data from many tools, notebooks, jobs, BI tools, every day. The first thing we did in this parallel phase was deploying the new system, the new platform that we developed in AWS, we deploy it. And we migrate all the processes that we have on-premise. And another thing we did was duplicating the transmission. So when an operational system is sending a file, now it's arriving in both platforms at the same time. But before starting the parallel, we also need to move all the data. We have 4 petabytes of data that we have to move it, and we have to do it very fast. We create our own system to transfer information because we needed to do it really fast. We have to stop the batch processing to do the copy, and we cannot stop the batch for many hours. So we developed our own system to transfer the information and started with a full copy of all the information, the 4 petabytes of information, to a new storage that we call copy data on-premise. Then we synchronize that data to the data in cloud, and with that we were ready to start the parallel. In that moment we start running 50,000 processes on-premise in cloud at the same time, and we did it during 1 week. After 1 week we stopped and start checking the results. At the beginning we have many problems with the processes executing in cloud. We have to fix many things.
Differences between the different...
And we have many differences between the data that we were getting in cloud that on-premise. So in the weekend we stop the batch, compare, and if something was wrong, we synchronize again. And we did this weekly for 6 months until the information in cloud was exactly the same that in on-premise. Our users need to test the platform as well. But at the beginning, they started testing with the new tools from AWS over the copy, because we knew that the copy was perfect. There were no problems of information in the copy. And once the quality in the data cloud was good enough, we moved the users to start testing the final platform, just before shutting down. Once everything was working, we delete the copy and we shut down the on-premise system, closing the migration. As I said before, to be able to do this, we develop our own transfer system based on EMR and this TP. And with this system, we can get very fast transmission rates. We can move more than 500 terabytes in 30 hours, or in weekly, we move more or less 100 terabytes in less than 6 hours. So very important phase, and was the key to be able to do a shutdown of the on-premise platform.
And what was the success rate when you decided to move? It was 90-something%, yes. Right?
Our go or no go criteria was to have at least 95% of the tables perfect, and not all the critical projects perfect. So at the end, we moved with a 97.
Yeah. Yes, so now this is very interesting. Also, how do we manage FinOps for the data realm in BBVA? Let's go.
Once the platform is in production, now the important thing is to keep costs under control. And this is why we created a department that we call FinDataOps. It's a division of FinOps, but it's focused only in data. What is this department doing? First, they are helping the financial departments in budgeting and billing. All pay-per-use strategy is something new for all the company, and financial departments are not used to work with pay-per-use. So we are helping them to look for these new strategies, how to bill, how to forecast the budget for the next year. Second, cost visibility, really important in any FinOps strategy. We work a lot, and we will see some examples later, in many information to give as much information to the users of the cost of what they are doing. So very important, if you want them to work properly, it's very important that they know how much are they spending in what they are doing. The governance model, this pay-per-use strategy creates new roles and new ways of working in the organization. So we have to define these new roles and define how they will work, and these new ways of working will be very important. But for me, the cost protection is the most important. We know that many users are new in cloud platforms, and they are going to make errors that is going to impact the cost. So we work a lot protecting these users, creating something that we call guardrails in the services that they are using, and protect them for these errors. And also, of course, we work a lot in best practice and continuous improvement, looking for new services that AWS is offering that can positively impact in the cost.
Yeah, so I think that as a best practice also, every new service that is incorporated into the sandbox, you will see later, that always goes through a guardrail process analysis, which is very important. And that brings us to the type of guardrails that we design for analytics and ML. One is the preventive ones, where we deploy this during the request, or the user configure the AWS services based on infrastructure as a service templates on CloudFormation. An example could be like the ones that we see here, EMR job execution controls, or Amazon Athena per query control limits, stuff like that. And now the detective ones. The detective ones, we deploy those, but using logs, trials, timestamps, consumption, being monitored by CloudWatch, CloudTrail, and so on. So those are the ones that are basically detective, and examples of these ones could be, for example, the alert generation when you reach a threshold leading to a guardrail execution, for example, and you need to stop a job. Or, for example, real-time analysis of Amazon EMR jobs metrics and logs compared to the guardrail limit on EMR, right? So those are detective and preventive. So based on those type of guardrails, so how do we avoid unintended consumption on ADA? How do we protect, how do we provide cost protection and especially cost visibility so the end user community is also well educated and is leveraging the resources properly in ADA?
Yes, if we come back to the high-level architecture, we can see that we have different risks depending on the size of the platform. On the left side is where we have less risk because there is nobody interacting with the AWS service directly. It's where, for example, we have our console, but the only people that is working there are the architecture team that is building the platform, and they are very highly skilled, so lower risk of having a problem. In the middle part, we have a higher risk. We have hundreds or maybe thousands of data engineers that are developing every day thousands of ingestion processes. We have to protect, even though these users are high-skilled users, we have to protect them to prevent any error that can impact cost. But where we have the higher risk is in the right side. We have thousands of users from business areas, some of them with no technical skills that are going to use the platform, and they are very likely to make errors that impact the cost. So we created different guardrails depending on the zone. In the middle part, for example, we create 9 guardrails protecting the service that data engineers are using, EMR and Glue. For example, we have guardrails that are checking the time a job is running, and when it's running for too much, it's stopped directly, this kind of guardrails. And in the right side, we protect all the services that our users use every day. For example, Athena, we have a guardrail protecting that if they execute a query that is processing too much information, the query will be stopped. So we are protecting them to avoid any error that will cause a negative impact in cost. But even with these guardrails, our financial departments were really worried. They were worried about how are they going to control the cost of the sandbox. What happens if a sandbox exceeds the budget and they don't stop working? This is why we created what we call the main guardrail. This main guardrail is monitoring the budget of a sandbox in every moment, and is sending alerts to the users when they are consuming the budget at 40, 50, 100%. If they don't do anything, at 200%, the sandbox is stopped, automatically stopped, and the activity is stopped. In that moment, the users has to review what is happening. Maybe they have more projects than they expected, or they are using a service in a no proper way, creating a bigger consume than expected. Once they know what is happening, they fix it, and they have to fix the budget. And then automatically the sandbox is restarted and they can work again. And cost visibility. AWS give us a lot of information, a lot of tools about cost. We have the Cost Explorer, the billing tool, but we think that we have to give as much information as possible to the users if we want them to be aware of what they are doing. We create our custom dashboards based on the Cure database, that you have all the information that you need to create dashboards. And in these dashboards, they can get all the information about the cost that they are spending. They have information at business area level, but they can drill down to see at department level or even on individual users.
Service levels as well.
And service, yes. And you can see every service and drill down by business area or individual users. And one important or nice feature that we offer is that we allow them to compare, for example, different business areas or different individual users, so they can see who is the best users and use them as a model for the rest of the people to work properly in the platform.
And you have a role, right? That is the sandbox owner, who is also...
Yes. Yeah. Sandbox owner is also checking what is happening in the platform. Is the owner of the sandbox and the maximum responsible from the cost. So they are all day working with these dashboards, looking what is happening in the platform in every moment, and if he see a user that is doing something wrong, they will work with them to fix the issues.
Yeah, so the future of ADA roadmap. One thing that we wanted to leverage is, in these times of generative AI. We wanted to basically to start a pilot, and we did that, and we can see that in the next slide. We did that to basically to provide a help chatbot for the end users. So we will ingest all the data coming from the operational documentation that we have in the platform to provide a semantic search as well, and leverage the information that we have. So we could have quickly help and reduce it, again, the time to fix the platform or the time to support the users within ADA. And if you go to the next one, so here we can also, one of the requirements was to support the Spanish. We work with Accenture, which is here with us, and basically quickly prototype this to demonstrate that we did this in a month and a half or so. So now end users could be, for example, asking questions like, how do I monitor a sandbox engine? Or what is Fireglass? Fireglass was the previous app stream that was used on premise, things like that. So it was a way to demonstrate to the end users that we could prototype this very quickly on the ADA platform itself. And now what is the future, the upcoming challenges on 2025?
Yes, we are really happy that our platform is now in production, but we have very interesting challenges for 2025. At the moment, we are only managing structured data, but if we want to satisfy all the use cases that we will have with generative AI, we have to start managing also unstructured data. We are working now in that. We want to improve our sharing and data collaboration between sandboxes, so we will continue integrating new capabilities that are appearing in DataZone that is evolving very fast. We also started to integrate online inference with SageMaker. At the moment, we only do batch inference. We are starting to integrate online inference now, and another storage in our data layer that is the feature store, so data scientists can train the models much faster. At the moment, we are only working with Parquet format that has some limitations. We are starting to explore new transactional data formats like Iceberg that is going to give us very interesting capabilities. And all you see at the moment is batch. These 50,000 processes that we execute every day are all batch processing. We are starting now to integrate real-time processing with Amazon Kinesis and to be able to have also real-time for some use cases. And one very important, we have a lot of data engineers. We execute 50,000 processes every day. We want to be faster developing these capabilities. This is why we are exploring new services like EMR serverless or Glue data quality, Glue ETL, so our data engineers have better tools. So, as I say, really happy to have the platform in production. We are now experiencing all the benefits from moving to the cloud and working with AWS, but we believe that the best is yet to come. Thank you.
Thank you.